So there are three possibilities for a pair of linear equations. Let me show. If I have like this, right, which we did earlier, 2x plus 3y is equals to 10, 3x plus 7y is equals to 30, right? These are the two. You see this, we solved and we got x is equals to minus 4 and y is equals to 6. This is the unique solution, right? There is only one pair which would satisfy both equations. When would this condition exist? When I have two equations, right? You see, just divide the coefficients of individual things, right? 2 by 3, and what is this? 3 by 7, and what is this? 10 by 30. 2 by 3 and 3 by 7 are not equal, right? They are different ratios at different fractions, and 3 by 7 and 10 by 30 are also not equal. That is when you'll have unique solution. That is, if I have equations like this, a1x plus b1y is equals to c1, a2x plus b2y is equals to c2. So a1, b1, c1 are the coefficients like 2, 3 and 10. a2, b2, c2 are 3, 7 and 30 coefficients. So when a1 by a2 is not equals to b1 by b2 is not equals to c1 by c2, then I'll have unique solution for the given pair of equations. You see this example which I was giving earlier, 2x plus 3y is equals to 10, 4x plus 6y is equals to 20. This is like basically into 2 gives me this, right? So see the ratio of the coefficients, 2 by 4, 3 by 6 and 10 by 20. All of them are 1 by 2, 1 by 2 and 1 by 2. All of them are equal. That's the case when I'll have infinite solutions. Because it's the same equation, right? I have only one equation which is being shown like 2. So when I have a1 by a2 is equals to b1 by b2 equals to c1 by c2, then I'll have infinite solutions. When would I see no solution? There's a chance that I would have a contradicting equations which would give me zero solution, which would satisfy both. That would be looking like this. 2x plus 3y is equals to 10, fair enough. If I have something like, let's say 4x plus 6y is equals to 30. You see what is the contradiction here? See 2x, 4x and 3y, 6y. If I multiply this with 2, what would I get? 2 into 2, 4x plus 6y is equals to 20. That is what the first equation is looking like. And the second equation is looking like 30. 4x plus 6y is 30, 4x plus 6y is 20. How can that be true, right? 4x plus 6y should be either 20 or 30. It can't be the same expression equal to two different things. So that's why I'm saying this is a contradiction, and that's why there will be no value in the whole number system which would satisfy both equations. I cannot have certain values for x and y which would give me 4x plus 6y equals to 30 and 4x plus 6y equals to 20. I'll only be able to satisfy this or this, not both. That's why I will have zero solutions or no solution. So when would that be? You see this 2 by 4, 3 by 6 and 10 by 30. This is 1 by 2, this is 1 by 2 and this is 1 by 3. So this ratio is equal, right? The coefficients of the variables 2 by 4, 3 by 6 are equal, but the constant terms on the right side, that ratio is not equals to. That is when I'll have no solution. That is a1 by a2 is equals to b1 by b2, but not equals to c1 by c2. That is when I'll have no solution. You know, why do we need to understand this, like a1, a2, b1, b2? There are certain set of questions that can be asked, right, which you can solve by using this not equals to like this. Right, we'll solve a question to show later, but just keep these points in mind, and fundamentally the fundamental logic of when would infinite solutions exist and when would no solution exist and when would unique solution exist. So this one, for what value of p would the following pair of equations have no solutions? If you remember this case, right, the no solutions case, as I said, when this is true, then I will have no solutions. As I said, this will be useful for us to solve the questions. So this is the example for that. So when will I have no solutions? a1x plus b1y is equals to c1. a2x plus b2y is equals to c2 will have no solutions when I have a1 by a2 equals to b1 by b2, but that is not equals to c1 by c2. What is a1 by a2? 2 by 8. b1 by b2 is 4 by p. c1 by c2 is 16 by 48. You know, this is 16 3s are, this is 1 by 4, right? This is not equals to. So this is not equals to. So that is correct. As long as I make p such that I get this 1:4 ratio, that is 1 by 4 is 4 by p. So p is 4 into 4 is 16. So I will have 2 by 8 equals to 4 by 16 is not equals to 16 by 48, right? This is 1 by 3, this is 1 by 4 and this is 1 by 4. So that means When P is 16, I will have no solutions for this following pair of equations. That's the reason why these things would be useful. If I had this, right, this is also not given to me. Okay, let's assume this is given as K. So when will I have infinite solutions? That will be when I have 2 by 8 is equals to 4 by P is equals to 16 by K. So this is 1 by 4. So 4 by P should also be 1 by 4. This, so P is 16 and 16 by K should also be 1 by 4. So K should be 64, so that 16 by 64 is 1 by 4. Right? That is how I can solve the question with no infinite solutions.